Hey there, and welcome to Into the Terminal, episode 79. I'm Eric, the IT guy Hendricks, and joining me is Mr. Scott McBrien.
Hey, Eric.
Hey there. Today we are going to be talking about managing your Red Hat Enterprise Linux systems with system roles. So, with that, let's dive in. And Scott, why don't you tell us what we're looking at?
Yeah, so on our critical path today, we're going to be using RHEL system roles, which are based on the upstream project Linux system roles, to apply some changes to our systems. So to get started this morning, first, why don't we install the software we need? So we're going to do a DNF-Y install RHEL system roles. And when we look at what's being installed, it's going to be the RHEL system roles, but also a package called Ansible Core, which is going to give us some Ansible content. And the RHEL system roles are based on Ansible. They actually work through Ansible roles, which is a type of Ansible packaging. So there we go. We're good to go. Got it all installed. So our goal this morning, or for this episode, is to talk about making changes across our system of population of systems to build a standard operating or like consistent configuration across the boxes. And you can see I've got this machine here that we're going to work on first, but I've also got this second machine and this third machine as well, right? But Ansible could go across hundreds, thousands of boxes. So for us, we're going to do 3, but realize that it could scale well beyond that. All right, so when we think about things that we would like to set on systems across our population, one of the things that I think gets often overlooked is time settings. And so here, this box is a RHEL 9 box, and if we use Crony, we can see that the machine is set to have a GCP-based time server as its source for time. And that's cool if my whole architecture is based in GCP, but what if there's like a mix between cloud providers or a mix between on-premises and cloud or virtual and cloud? I might want to have a consistent configuration for this across the whole gamut of systems. And that's where a system role can be really handy. So we're going to put together a quick playbook to set time across all of our boxes. So I'm going to create a file called time.yaml. And I've already written this out. So I'm just going to copy and paste it so that we don't have typo problems.
Typos are never a problem on this show.
I know. All right. And I missed a line, looks like. There we go. All right. So what we are doing is down here under roles, right there. I'm importing or referencing the RHEL system role called timesync. And timesync is a role that allows you to set time settings, NTP server settings on the machine. Right up here in the hosts, what machine should we do this with? Right now, it's going to be localhost, just this box. But in a second, we're going to like push that across our whole fleet. And then the vars field is what are we going to change on this set of systems? And so what I'm going to do is I'm going to define what I want my time servers to be. So one of them is a NIST.gov server. So if you don't know, NIST is the National Institute of Standards and Technology for the United States. And one of the things they do is they maintain time servers and also have an atomic clock at their disposal. The other one is a RHEL pool out of ntp.org system. So that uses DNS and round robin DNS to just like pick a volunteers system that they have configured for ntp.org to service as other people's time servers. And depending on who's doing the query or when the query is happening, you could actually end up with different boxes being reported back. So I'm going to take one pretty high quality time source of a NIST.gov entry, and then I'm going to take another time source that is probably reasonable quality, but probably not as good as the NIST.gov one. And I'm going to make both of those my time servers. I may also want to add in a third one just to make sure that if there's a differential, the third one can help break the tie of a differential. Anyway, so here we go. Solely quit. And what we're going to do is we're going to run this playbook. All right. So this playbook is running. It's actually doing a bunch of stuff. One thing is it's checking the software that's installed on this machine. Because over time, we have changed what provides NTP. So back in like the RHEL 7 days, it was the NTPD daemon. And then in RHEL 8, it became NTPD or Crony. But NTPD was the default. And in 9, Crony is the default, and NTPD is still shipped, but is not the default. And so one of the things the system role does is it actually looks to see which of the included technologies is being used on this machine. Because if we don't identify which technology is being used, how do we know whether these time server specifications need to go in NTPD configuration or Crony configuration? And so the time sync system role figures that out and then makes appropriate changes to the system.
Well, and I think it's good to point out that not only does that work against different sub technologies like NTPD versus Crony, but that also allows you to run Ansible playbooks against different versions of RHEL. So we're running on RHEL 9 today, but we could just as easily use this playbook on, say, RHEL 8.
Well, and we talked about client systems being out there. They could be different versions of RHEL. And so we can use the same playbook on this being a RHEL 9. Maybe client 1 is a RHEL 7. Maybe client 2 is a RHEL 8. Well, the same playbook will make the context appropriate decisions across all of those options. All right. So we've got it. Let's just verify that works. So if I look at my Crony C sources again. Uh-oh.
Looks like you're trying to scroll. Hit Q.
Hit Q.
Yep, there you go.
Ah, there we go.
Love
All
me
right,
some
so there we
T-Monks.
go. Yeah. So we can see that on this machine, we've got our time.nist.gov server, and then we've got a random one that we pulled out of the ntp.org pool of systems. All right, but I said we want to not just do that on this box, we want to do it at scale across all of our boxes. So the next thing I'm going to do is I'm going to create a host definition to say, what does my population look like? So I'm just going to create an ini file. And again, I've typed it out. All right, that looks right. And I'm going to update my playbook to say not just localhost, but also this group of machines called clients. And then when I call the playbook this time, check because that was kind of weird. Okay, cool. When I call the playbook this time, I'm going to also pass this host ini file, which defines what clients means, like the list of systems that are included in that. All right, so now when it runs, you can see that it's connecting to both localhost, client 1, and also client 2, and it's going through and making these time changes across all of them. And then once it's finished, I can connect into client 1 or 2 and verify that it also has the named NIST server, but then also a random one pulled from the NTP pool. right? So I can message over here, and I can do a crony C sources, right? And it's got the named machine plus this other random one we pulled out of the pool. And all three of my boxes are now configured like this: a named machine plus a random out of the pool. All right, so that's a quick introduction to using system roles. Keep with us after the break. We're going to talk more detail on system roles, but also don't forget to like if you enjoy this content. Hit subscribe if you want to be notified when we do more content, or if you know a friend who would also be interested in this, share the video with them.
So shout out to Nate Lager, who is traveling today and graciously let me fill in for him. So we're actually hoping to do a two-part episode, or two episodes back to back on system roles. We're talking about managing configuration, and then next week, Nate will be back, and we'll be talking about more operationally things like deploying workloads using system roles. So. Of course, I got to give a shout out to my buddy Brian Smith, who helped us plan this episode. He is the product manager for System Roles and my co-host on RHEL Presents. So definitely got to give a shout out to Brian for that. I think one of the fundamental questions we have to answer is why use system roles? What are they, and how do they help? There's actually a question in the chat from Shantanu about could I have different NTP settings based on, say, cloud provider? And that is where system roles really come into play, because at their core, pun intended, they are Ansible playbooks, and you could set up. For today's example, we just did hosts equals all basically, and so all of our systems that we put in our inventory file will get the same configuration. But Shantanu mentioned that, well, I might feel more comfortable if I use the cloud's provided NTP servers. So AWS using AWS NTP, Google Cloud using GCP. Sorry, it's not GCP anymore. I guess it's just GC. Anyway, Google Cloud using Google Cloud NTP servers. So whatever the cloud suggests, that's what those systems get for their time source. And that's one of the benefits of using something like system roles, is that you can set up playbooks to target certain groups of hosts. So if you had different systems in different regions, you could definitely have different configurations for those.
Yeah, and later on in the episode guide, Eric, I provided a link to a lab on establishing standard operating environments. And one of the things that we do in that lab is make changes to the kernel performance settings of a machine. And I pulled those kernel performance settings out to be what one would set for a database workload like Postgres or MariaDB or MySQL. But you'd want to target those at a set of databases. You wouldn't necessarily want to use the same settings on web servers or the same settings on hypervisors that you're using for virtual workloads. So in those cases, you would want to specify either in the host INI, like we did, a specific set of boxes that corresponded with the set of boxes that were your database servers, so that only those got the updates. You can also do that in a playbook with some logical operators in the playbook to say, if you're this group of hosts, apply this section of the playbook, otherwise skip it. So there are a couple different ways that we can write one playbook and then have it go to different places. All right. So one of the other things, Eric, we talked about Ansible, and we saw when we installed, we got Ansible Core, and we're going to talk a little bit about what that means, because Ansible is like this really broad pile of stuff.
Mm-hmm. So one of the differences between, say, Ansible and Ansible Core is that Ansible Core is trying to think of a different word other than core, but is it sort of the essentials of the Ansible tooling? It is a lot of the modules that are included in Ansible Core allow you to execute certain tasks. One of those tasks are system roles. Some of the other modules in Core, I believe, are like user management. There's a few other modules. I meant to pull that up before the show, but
yeah, it also basically we make sure that Core works with all of the automations that we provide as part of your RHEL subscription. So system roles is one of those. OpenSCAP remediation playbooks is
Mhm.
one of those. Insights provided advisor playbooks or update, CVE mitigation playbooks are those. So realize that there's also a upstream Ansible, there's product Ansible that you can buy from Red Hat. And so we wanted to include Ansible capabilities in RHEL. And the thing that we include is a piece of Ansible that can do all the things that we tell you can do with Ansible in RHEL. Now, you could potentially do stuff outside of what we told you is a supported thing, like write your own playbooks to do stuff. But your mileage is going to vary because what's provided in Ansible Core is not what's provided in the community version of Ansible or the product version of Ansible, Ansible Automation Platform. So be forewarned that we ship Ansible Core because we want to enable these specific things. Anything beyond that is on you, and if it breaks, you get to keep all the pieces. But we test things like system roles and remediation playbooks and OpenSCAP playbooks.
And to kind of zoom that conversation out a little bit more, there's a question about why we weren't installing via Ansible Galaxy, and then that same logic applies. Ansible is a huge community. I believe they're hosted out on Matrix. They've got a Matrix space, I do believe, um, and so the Ansible community is huge. And there's things out there for everything, all the way down to managing your Minecraft server using the community of Ansible. But not all of those things are going to be useful in an enterprise environment. I mean, I don't know about you, Scott, but I think our team needs a live stream Minecraft server. But most banks and government organizations and whatnot aren't going to find all the community pieces useful. So those don't get tested and slurped into what RHEL then repackages as Ansible core. So there's this symbiotic relationship between the community development pieces and the pieces that actually get repackaged and shipped as part of RHEL. And I see that Terry's hanging out with us in the chat today, and he made a good distinction as well, that even carries down deeper into even the system roles. So what we're demonstrating today are RHEL system roles. So you can take your RHEL system, follow these exact steps, and there would be 20 some odd system roles that you can use. However, those system roles are actually based upstream, because here at Red Hat we love upstream first. That's kind of our mantra. And so everything that you see us working on are based on upstream efforts. And in the show notes, we'll link the GitHub repository for Linux system roles. And those are, again, community driven, and they drive a lot of the development that you see for the downstream RHEL system roles that come prepackaged with Ansible Core.
Yeah, and just another note on Galaxy. So I was at a conference a number of years ago, and another Red Hatter came up to me and was very unhappy about something Ansible. And through the conversation, what we discovered was that he had pulled down a Ansible role from Galaxy. It was not a RHEL system role. It was a generic, I went to Galaxy, I found this role I was interested in, I applied it, and it did not work. And it's like, well, that's because it's community. So what we're looking at with RHEL system roles, these are the roles that as Red Hatters and RHEL product people, we're saying we test and we will make sure that they work. Anything you might find out there that's Ansible roles and Ansible Galaxy isn't coming with that same backing from us that says we will make sure that this works. We will make sure that this works across versions of RHEL. But the things that you get from RHEL system roles has that level of testing and backing from Red Hat. The Linux system roles project, which is the upstream for RHEL system roles, is predominantly contributed to by Red Hat employees. So that's like not Galaxy, but is affiliated with the Ansible ecosystem. And even though it's an upstream project, the majority of the work that happens there is happening from Red Hat engineers. And once they say, "Hey, this is great, we're ready for it," it gets passed into RHEL system roles, where it's packaged and deployed as part of RHEL as a general availability software.
Awesome. So I think actually it may be easier to show instead of tell. Why don't we take a look at what system roles are available inside of our RHEL 9 machine?
Yeah, so earlier I installed the RHEL system roles package. And if I did some RPM queries, I could show you where I came up with this, but essentially it drops all of the role data in user share Ansible roles. And so the ones that say Linux system role are symbolic links to the ones that say RHEL system roles. So we have AD integration, certificate, cockpit, crypto policies, firewall, HA cluster, journal D, KDump, and the list goes on. Eric mentioned that we're going to be doing a show next week on this as well. So this week are the things that we would do across our system to make kind of a standard configuration that we'd want across our population. So in just a minute, we're going to do a couple more examples, but we started today with time sync. The other examples we're going to do today are T-log, so enabling session recording across our machines. And then we're also going to be doing journal D, which will allow us to create a persistent journal D or journal for all of our machines with journal D. So out of the box, RHEL doesn't have a persistent journal. And we're going to use a system role to make sure that all of our systems in our population have a consistent journal. Out of the box, RHEL doesn't record people's sessions with T-log so that we can play it back and look at what happened at different shell states of the machine. But we're going to go through and enable our machines across the population to start tracking and logging that data. Some others of interest that I thought about for today's show but decided against, postfix. So if you have a bunch of mail servers, this is how you can get a consistent configuration across those mail servers. SSHD. You want a consistent SSHD configuration. Maybe you're going to passwordless authentication. This is how you could apply that change across. What else? Metrics will configure Performance Copilot to start reporting Performance Copilot data to a central host. So if you're doing things like monitoring, that might be interesting to you.
Seriously considered SSH, but didn't want to accidentally typo a playbook and then not be able to connect to our lab. But
Right.
the SSH and SSHD system roles, so client and server, respectfully, are really really handy, especially if you want to disallow like root logins or disable password logins and require keys. So there's a lot of different configuration options for the SSH and SSHD system roles.
Yeah, and firewall is another one of those where it's like, these are the firewall rules I want to have set on my machine and across my population. Next week, we'll be talking about roles that provide system administration tasks. So ones that we're thinking about next week are things like network, so making changes to the network configuration. Podman, how do I define containers that I want defined and available on the hosts out in my population? SE Linux. So not only can you do a system-wide thing like change it from enforcing to permissive or change the policy that you want, you can also actually set things like file contexts that should be applied across, or SE Linux port labels across. But typically those things tend to be more specific, like you figure out that something's incorrect and now you need to apply it across your population, right? So it's not necessarily a golden image or a standard build option. Storage. I need to change my storage configuration, either adding partitions or growing logical volumes or other stuff like that. So these tend to be more operations, event administration driven roles, rather than this is something that I want to set on all my machines in my population identically. So that's the difference between the two episodes. Today, we're talking about some basic configuration that we apply across all of our machines because that's generally how we want them to operate. And then next week, we're going to be taking a look at system roles. Nate, pay attention. We'll be taking a look at system roles where we can execute changes across our population or subsets of our population.
So we've got a few minutes left, and our discussion pretty well covered a lot of the questions in chat. Why don't we set up another system role or two?
Yeah, so I'm going to just add on to the existing time YAML. So even though it's a really poor name now, because I'm going to be doing things other than time, we're going to add some other pieces into it. One of the things I also like about system roles is they come with a lot of documentation. So if we look at user share doc RHEL system roles, there's documentation for each of the included system roles with RHEL. And one that I'm going to start with is journal B. And there's in this directory of content, notice there's an example playbook. So this is what it would look like if I wanted to do a persistent journal for journal D with system roles. So I'm just going to take this and I'm going to append it into my existing time YAML. But now it's in a weird place, so I need to kind of mush it into the right format. So number one is I'm going to reference the journal D role in the role section of my playbook. Try that one more time. There we go. So we're going to reference the role in our role section, and then we're going to grab these variables. How many are there? 1, 2, 3, 4. And we're going to put them in the variables section of our playbook. So now my playbook is going to do two things. It's going to set the time servers, and if somebody had messed with the time servers and changed them, it will set them back upon the next run. And then it's also going to run these journal D things if they have not been run on the host before. All right, so just to prove that we didn't bake a cake and are substituting it on you, if we look at var log, what we are missing from var log is a journal directory. Okay, so I'm going to run my playbook again. Right, I'm going to tell it to run the playbook using the hosts of my host INI. All right, so we can see that it's doing the time sync stuff, but it's going to go through that pretty quickly because there's nothing to do there, right? See the skipping because it's already done. All right, and a little bit further, it's going to then get to the journal D settings. And so you can see the task RHEL, system roles, journal D stuff, and then it starts doing the journal D settings. Right, and then it also made sure that the journal D configuration was reflected in the service unit, and it went ahead and had it flush the existing contents of the journal to the brand new log file it created. And so if we list our log now, there's journal. And underneath, there's the journaling that we're doing. And if I looked across client 1 and client 2, we would see the same thing. All right, and if we want to keep going, maybe we want to enable session recording. So Eric, there was a Into the Terminal episode where we covered session recording, wasn't there?
Yeah, that's going way back.
Yeah. But that episode, what we did was we went into Web Console, right, Cockpit, and we enabled it and we set the settings on like who should have their session recorded and a bunch of variables that we could have changed, but we kept the defaults. Things like what message should be displayed when someone logs in and stuff like that. Let me show you what that looks like. The same exact setup that we did back then, but via system role.
So 23, in fact.
All right, so we include the role. So now we know how to do system role or session recording things. And then we're going to add in a variable somewhere.
So while Scott's playing with copy paste, now we called out that we're doing all this in a time.yaml configuration file. What you'd probably want to do at this point is rename that file to something more like prod, or maybe the name of your data center, or maybe this is your AWS config, something that would tell you that this is a config specific to a certain environment.
How about that? We'll just call it
That works.
settings YAML. All right. So we will recall our Ansible playbook, but we'll update its YAML file. All right, so now it's going to do the NTV settings if it needs to, which it shouldn't because we didn't make any changes. It's going to do the journal persistence things, but it shouldn't need to because we've already made it persistent. And now it's going to do the session recording tlog things, and that's new. So that'll take a minute to get executed.
Well, that's running. No major typos or kerfuffles today. I'm really excited. So if you're watching this, you should definitely hit that like button and share it with a friend, because we didn't really do any troubleshooting today. I'm excited. Scott, we should cancel our team meeting later on today. We should just call it a day.
And on a high note.
Right. Things can only go down from here.
All right. I do want to call some attention to what we're getting across the screen here. Notice right here, the task, it says install session recording packages. So as the system role was running, it saw that I didn't have the tlog program installed on these boxes, and it went ahead and did a DNF install to get it. tlog was available in RHEL 8 and 9, but if this is running on RHEL 7, it would have skipped it because it's not applicable for RHEL 7 hosts. All right, so here we go. System role is done. I'm just going to SSH over to client 1 again. Notice the message. Attention, your session is being recorded. All right, I can do some stuff. And I can exit. And I'm just going to flip over to the client 1 tab here.
I spoke too soon.
Oh,
there it is.
All right. And is it messages or secure? I thought it was messages. So we need to specify a. See, this is what happens when we go off script, Eric. We need to specify a. Okay, so here it is. There's my tlog session that was recorded. And this is me running, looks like the df command.
Yep.
So literally, going back to my primary host. One entry. tlog scope SSSD all. Everyone should get their sessions recorded. Make sure to use the role definitions included in this RHEL system role called tlog. And it installed the software, enabled the service, started doing all the recordings, and now you can do playbacks and other stuff before. So very easy to make a configuration change and just blast it across your population.
And with just installing a couple of packages, writing a very small YAML file, we can blow that up to. I mean, we just covered 3 system roles on 3 systems, but that could easily become 20 system roles across 20,000 systems. And I'm not exaggerating, because there's companies out there that utilize system roles to that scale. So this is, in my opinion, this is becoming an essential tool. This is something that every systems administrator should be using, because I don't know about you, but I got tired of opening like 20 screen or 20 tmux sessions and going into each of my systems and going in and editing every one of those files on every one of those servers by hand, manually. It's just, you don't have to do that anymore. Don't do that to yourself. So I'll make sure to include links to the upstream Linux system roles, to the T-log episode. Sounds like a couple of people had a question about it, so we'll include that episode as well. So upcoming events. Today is Linux's 32nd birthday, so happy birthday, Linux. So 32 years ago, Linus Torvalds sent out that call to, hey, look at this thing that I wrote. So that's really awesome. August 25th is the date of recording. Next week, Nate will be filling in for me on the Modernizing RHEL Management mini-series, talking about Red Hat Insights. They'll be looking at compliance. So looking at how Red Hat Insights can help you manage compliance across HIPAA, PCI DSS. We mentioned that OpenSCAP workbench. So check that episode out next Tuesday. Next Tuesday evening, I'm actually hosting a Fedora podcast episode talking about Lenovo laptops and Fedora. So if you're interested in the upstream community, go check out the Fedora YouTube channel. Shameless self-plug. And then next Wednesday, Nate and Brian Smith and I will actually be talking about an introduction to Identity Manager. Or I'm sorry, that's in 2 weeks. It's 2 weeks. We just had an episode. So if you missed Wednesday's episode with Brian and Randy Russell and myself, we got in real deep and talked about why Linux, why open source, and kind of a look at why Red Hat does what it does and why each of us do what we do. So great episode on RHEL Presents this past week. And then as we've hinted, a week from today, join Scott and Nate should be back from traveling to talk more about operationalizing system roles and how you can use that with workloads and to kind of stack on top of what we talked about today. Scott, anywhere else you want to send folks?
Just happy Into the Terminaling, everyone. Until next time.
You just had to throw that in there. All right, folks. Have a great weekend.